Hi everyone. Today let's look into the problem permutations. This is the problem 46 of LeetCode. Given an array nums of distinct integers, we should return all the possible permutations possible for that array. So by permutations we mean arrangements. So if you are given an array 1, 2, 3, then all the possible permutations include basically different arrangements of 1, 2, 3, which includes 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and so on. For any given array, the number of permutations possible is basically n factorial. Taking this into account, now let's see how to solve this problem.
Let's take the above example 1, 2, 3 and see how to solve it. Okay, so to start with, in a simple terms, at 0th index we have three options. We can either go for 1, 2, or 3. Now in the path where we come with 1, then the options that we have for 1 is 2 and 3. And similarly, if we just take this path alone, then the next option is 3. Basically, similarly here we can have 2. The same extends for basically all the other elements also. But if you see, this is not a like to explain, this looks simple, but if you see, actually implementing this is very tricky. There is another better way to implement this solution. So what we can do here is take like at each level we know that we have 1, 2 and 3 because these are the elements in our nums. So now this is a backtracking technique. So what we will do is we will iterate through the array as long as and recursively call the array until we reach the end of the array. When we reach the end of the array, we return an empty array. Okay, then what happens is we will insert 3 into this array such that as a result now we will get all the arrangements of 3 possible with this array, with this set. The next is, then what we do is, now given 3 we will insert 2 in such a way that we get all the possible arrangements of 2 and 3. And similarly, and finally what we'll do is, in this arrangement of 2 and 3 we insert 1 such that we get all the different arrangements of 1 and 1 along with 2 and 3. So this is the approach that we will look into. Let's do the code for this. So to start with, we'll write a DFS function, which is basically nums, which will take argument as the current index and nums. So let's put it here. So this will be this will return the array of vectors. Okay, and let's put this as underscore DFS in I, comma our vector of numbers. Okay, we could do better. If you want, we can even set this as a private variable and then access it, but I'm just going to implement it this way. So now to start with, let's take the exit condition. If I is equal to 0, sorry, I is equal to nums dot size, then we have reached the end of the array, and what we can do is we can return a empty array. Otherwise, on the normal flow, what we will do is we will get the return parameter, which is basically an array of vectors, which will be, or basically array of arrangements that is possible. So this will be I plus 1 comma nums. So once this starts backtracking, then we will try to create our output array, which we have to build from the current array, which is basically all the arrangements possible with the current index on top of the current array that we got as a return value. So that will be we will take each element of current array. So that is auto, I'll just put j is equal to 0, j less than car dot size plus plus j, and then for auto k is equal to 0, k less than car of j dot size. It should be less than or equal to, because we want to insert k in all the different positions within that array, basically to get all the arrangements. So that will come down to we can tell outer dot push back curve, and this will be then out dot back dot insert. So we will have to insert it into the last elements kth location basically. Okay, so this will be plus k comma nums of I. So this will be run out. Let's see if it builds properly. Okay, I see a problem here. So let's see, this is car of j, so that will be okay. Let's see what's the problem. Oh, my bad. So this should be begin plus k. Okay, let's see, underscore dfs 0 comma nums. Oh, sorry, semicolon. Okay, so I think let's submit and see what is the result. So as you can see, LeetCode accepts this solution. Just to give you a heads up here, time complexity, let's see, right? So anyway, we will have to go through n factorial, which are the number of possible permutations. But as you can see here, we will have for each n elements, we could have n insertions. So n elements in current, we could have n insertions. So that means that it will be n squared into n factorial, and space complexity, as you can see, there also we will have n factorial elements, but everywhere you will see a dual copy. So this would be n. So that is the space complexity associated with this solution. So that's it. Thanks everyone. Thank you. Bye.